on page 124, they have this example, and we already talked about this being a second method for rationalizing the denominator, where we're going to multiply by something that makes a difference of squares. And in order to make the difference of squares, it has to be exactly the same, but one is plus and one is minus. That's what makes a difference of squares. So we have another new definition that you're going to learn today. And in math, we call two binomials that are exactly the same. The only thing different is the sign in between, conjugates of each other. So if I had, for example, 2x plus y, if that was one binomial, the conjugate would be 2x minus y. If I had 3 minus a, that's a binomial, the conjugate of that would be 3 plus a. So you're going to hear this word. It's a little bit rare, but it comes up here. It's going to come up again in grade 12. It's going to come up in university. That when you have the same binomial, but the number in between is different, the sign in between is different, those are called conjugates. And a difference of squares is always multiplying two conjugates together. And what happens is that the bottom, the square roots, nicely go away, and you have rationalized your denominator. So at the bottom, if you want to put a highlighter box around this, the definition of a conjugate, that's perfect. And now we're going to rationalize the denominator when we have a binomial. So I'm just going to start. The first thing I'm going to do is I'm going to rewrite it, and while I'm rewriting it, I'm checking, is there anything I could reduce further? Can I reduce the root 6? No. 3, I can't reduce the root 2. So I did a quick check. Is it in simplest form already as far as each individual term? Because if you can simplify it early, life gets easier. Yes. Next. I'm going to have to make the conjugate create a difference of squares on the bottom. So that means if I want the difference of squares, I need exact same numbers, but a different sign. So we'll have the root 3, root 2, and the 4, but now there will be a plus sign in between. And in mathematics, when you have a fraction, there's like invisible brackets here. You're multiplying by another fraction, invisible brackets there. If I multiply the tops, you see that you would have to FOIL, because you have a binomial times a binomial. So you can draw the arrows. This has to get multiplied by this. Tons of mental math about to happen. Tons of opportunity to make those small mistakes. So take your time. Be careful. We're going to multiply out the top. So 4 times 3 root 2. 12 root 2. 4 times 4 plus 16. 4 times 3 root 2. Oh, I did not work. See, you have to be careful. Now the inside. 2 times 3 will be plus 6, and root 6 times root 2 is root 12. And then 2 times 4 is plus 8, root 6. That'll be the top. On the bottom, since the difference of squares, right, I can write it out as a difference of squares. It's the first one squared minus the second one squared. Okay, we have to keep simplifying. On the bottom, if I square 3 root 2, I'm going to get 9 times 2, 18. If I square 4, I'm going to get 16. So the bottom is 18 minus 16. On the top, do we have any like terms? There's 4 terms on the top. Are any of them alike? No. Do we have any that can be simplified more? Check your square roots. Can you simplify square root of 2 more? No. So that one's going to stay 12 root 2. 16 is just a number. It can't be simplified anymore. Can you simplify the square root of 2? Sorry, square root of 12. Yes. The square root of 12 is 4 times 3. So if I pull out the square root of 4, square root of 4 is 2. 2 times 6 is 12. This becomes 12 root 3 plus 8 root 6. Okay, now that you simplified, are there any like terms on the top? And you see the bottom can be 2. No like terms on the top, so the top is done. Just rewrite it. All I can do in this step is simplify the bottom. Is this in lowest terms? No. Can you see that everything, there's a number that divides everything? Can you see that everything can be divided by the 2? So if everything can be divided by 2, you have to divide this one by 2, you get 6 root 2. Divide this by 2, you get 8. Divide that by 2, you get 6 root 3. Divide this by 2, you get 4 root 6. And then divide the bottom by 2, you get 1, which don't have to write on the bottom, divided by 1. Whew. Lots of mental math before we get to the final simplified answer. One mental math mistake, and life gets difficult. So we have to be really careful, take our time. I'm going to tell you, grade 11 is going to get you really good at your mental math. Part B. First of all, I'm going to rewrite it. 3 root 3, 2 root 3 minus 4 root 6. All divided by, and while I'm rewriting it, I am checking if there's anything I could simplify right away, plus 2 root 3. And there's nothing that can, none of the square roots can be simplified further. No like terms on the top, no like terms on the bottom. So I'm going to need to multiply by the conjugate to get rid of the square root so that I can rationalize the denominator. The conjugate means the same binomial, different sign in the middle. Same binomial, different sign in the middle. And again, there's like these brackets there that are not written. So on the top, we're going to have to FOIL and draw all the arrows. Lots of mental math happening. And the bottom is a difference of squares. So I can write it as a difference of squares. It's going to be 3 root 2 squared minus 2 root 3 squared. Okay, so on the top, first arrows, 2 times 3 is 6. Root 3 times root 2, root 6. Again, you are trying to be one step ahead of me each time so that you can double check your mental math. Second arrow, I'll get minus 4, root 3 times root 3. Ooh, root 3 times root 3 is just going to be 3. I could have written 12 already, but I already wrote my 4. Are you okay if I just put the 3 in brackets there for now? So sometimes it's going to happen in your mental math. You'll be like, oh, I multiplied the numbers out in front. I could have done more, but I'll just do it in the next step. It's perfectly fine. Next arrow, negative 4 times 3, that will be negative 12. And root 6 times root 2. Will be root 12. And finally, negative 4 times negative 2 is plus 8. And root 6 times root 3, root 18. Okay. On the bottom, definitely can figure this out. So 9 times 2, that will be 18. 2 squared is 4. 4 times 3, that will be 12. I'll get 18 minus 12 on the bottom. And we'll do some simplification on the top. 6 root 6. Can't simplify. 4 times 3, definitely, we can get 12. Can you do anything with the other square roots? Are they in lowest terms? You can reduce them, right? Because 12 is 4 times 3. And the square root of 4 is a 2. That 2 comes out in front, hits that 12 because you negative 24 root 3. I would say at the beginning, whenever you simplify a square root, do a quick double check. Tons of mental math mistakes happen when simplifying square roots. 18 is 9 times 2. Square root of 9 is 3, so the 3 comes out in front. Hits the 24, and I'd be left with the square root of 2. Now the bottom simplifies to a 6. Any like terms on the top? No. The best I can do is rewrite the top. And I know that seems a little bit annoying, but if you were actually counting the seconds that it took me to rewrite the top, it probably came out to maybe 2 seconds, maybe not even. It actually takes longer to think to yourself, ooh, it's annoying, I don't want to rewrite the top. It takes more time than actually rewriting the top. I will tell you, though, that if you get annoyed and start to skip steps, you will make mathematical mistakes. So it's a good idea. I just had to rewrite the top. And now, is this in simplest form, or can everything divide by something? 6. Everything divides by 6. So I get root 6 minus 2 minus 4 root 3 plus 4 root 2. And the 6 on the bottom would be 1, so I don't have to write that. No like terms. Everything reduced to lowest terms. This is the simplified answer, which still looks quite complicated. So now you can circle 10 and 13. I